As far as a rollout, there are 8 stations planned for Irvine, and here you see 8 stations. Here's 2010 rolling out through 2014, 8 stations. And this is part of a planning tool to try to identify a scenario for the optimum evolution of those stations. But there's a constraint where the state is saying that you must have the hydrogen reach a level of 33% renewable, and that's constraint is shown right here. And each of the colors in these plots represent a different source of the hydrogen. Now up here, this particular scenario is what we call a realistic scenario of available renewable resources along with conventional resources. And you can see that through 2014, to meet the daily kilograms of hydrogen required by the public, one is able to meet the goal of the state to exceed 33% renewable hydrogen. I don't want you to leave so much with these numbers. I just want you to appreciate the kind of planning activity that is currently ongoing to help guide that infrastructure deployment. This is a big part of it, a very wild diagram, which is life cycle analysis. You'll hear more about that this afternoon, but allows us to evaluate from cradle to cradle, from the provision of the raw materials for hydrogen to the final vehicle dispensing, the energy, the environmental, and the economic impact, as well as the impact upon water. So pleased that Mike Didinger mentioned that this morning. It's a critical need, but it's a fascinating opportunity as we transition this paradigm to a new future of the fuel cell vehicle and the fuel to do it with a zero impact on water. Zero impact on water. Do it without the need for water. Let's just look at some of those outputs and take, first of all, the greenhouse gas emissions. This is what that looks like from 2010 to 2014. This is the grams per mile of CO2 emitted. And these purple bars up here show what the Air Resources Board believes for each of those years the most advanced population of automobiles, gasoline on the road will achieve. This red line is the 30% reduction that is required by the state Senate that we need to reach. And then these 3 colors here are different scenarios for the provision of hydrogen over those years. The orange is a more fossil fuel intensity, like steam methane reformation, with not much renewable. The green is a aggressive renewable strategy, which probably cannot be realized. And then the purple is a realistic combination of both. And as we look out here to 2014, we can see where we'd be with a really realistic strategy for the reduction of the CO2 with this population of automobiles compared to the gasoline vehicle at the same time. We keep talking about CO2, and we have not solved yet our ozone, our urban air quality. And we need to keep that in mind in our planning to see what that's going to look like. We start out there with the criteria of pollutant emissions because that's the source of photochemical smog. But then those are spatially and what we call temporally distributed around an area like the Los Angeles basin. So we need to identify that spatial and temporal distribution. Here, for example, is the LA basin. You kind of recognize it here. Here's Catalina. These red dots represent what we believe would be hydrogen stations in the year 2060. The red lines represent hydrogen pipelines coming from different renewable resources, such as wind farms in Tehachapi and Beaumont, so on and so forth. So that's getting into this spatial distribution. The temporal distribution, well, let's get to that in a moment. Let's look at a highly refined spatial distribution. What we're doing today is actually go down to the actual intersections. All these little dots here represent refueling stations in the future. The blue dots represent central but regional steam reformation sources of hydrogen. The green represents trucking routes to truck, and the red represents pipelines. All of that has to be taken into account in order to establish the environmental impact of this. But from this very detailed spatial and temporal distribution, meaning temporal, the variation of time over 24 hours that a truck would be operating, or a pipeline would be operating, or stations would be in use, we're then able to go into an air quality simulation and project the future. This is 2060 with respect to ozone, one of our major secondary pollutants that we have to control, and particulate matter, in particular PM 2.5 we call it. Won't go into details here, but just want you to see that up to a 10% reduction in hydrogen vehicles in 2060 versus the best gasoline vehicles, and 15% reduction in particulate matter. That's going the right direction, but these still do not satisfy the National Ambient Air Quality Standards of the Clean Air Act of 1970. And of course, we have many other sources that have to be taken into account. But as we focus on CO2, which we must do, this is where people are living, and this is the public health aspect of the impact of transportation, electric power generation that we cannot ignore. This was recently published in a Environmental Science and Technology, or will be, I guess. It's on the web, but hasn't yet hit the hard copy yet.